Yeah, hello everyone, and welcome to the third session of AZ-400. That is define and implement continuous integration. This is going to be our first session for this module. We have divided this module into two parts. So today we are going to have first part of it, and then the next session that we have scheduled on 25th of December. That will be 26th of December. That will have the next part of this particular module. So let's go ahead and start this thing. Before we start, we just want to acknowledge the people behind these sessions that we are having. Uh, Neeraj, who is behind Azure Talk community, who has been helping us to uh, kind of conduct all these sessions, helping us with the resources, helping us with the knowledge, and helping us, bringing all of us together to bring this particular concept in action. So Neeraj is our founder of Azure Talk and Azure Easy community. uh, After that, we have Ram Murthy, who is based out of Bangalore. He is also a active community member, and he works behind the scene to help us to arrange all the content and everything that we are trying to present here. So maybe you are uh, seeing these two presenter or three presenter, but behind the scene there are a couple of people who are helping each other to bring the quality content that we are able to present here. Then this is me, Ashish. I am based out of Bangalore. I am DevOps architect, and I will be taking first part of session today. And uh, then we have Vipin, who is a Microsoft certified trainer and a freelance consultant for Azure. And he has conducted our training on Azure Administrator and Fundamental previously, and he is working behind the scene to arrange all these sessions to help us with the content and everything. So we would like to thank him as well. Now we have Rahul, who is our network architect, and he helps us all the wherever we need some sessions about networking and or cloud in general. So we Rahul has conducted few sessions in past, and then he is helping us behind the scene to bring all the content. We have Kritika, who is also working behind the scene to help us with the content, with the sharing the information in social media and everywhere. So Kritika is also one part of our Azure Talk team, who is taking care of all the things which are working behind the scene. And then Nitanshu, who is going to take the demo session today, and also he's part of the core team member who is helping all the team members, all the presenters, and all the speakers to bring the best out of that best content. So let's go ahead and just talk about the today's speakers. That is me, Ashish. We have already discussed about. I am Microsoft certified trainer and also a DevOps architect, currently working and currently based out of Bangalore, India. Then we have Nitanshu, who is based out of Delhi, and also a cloud consultant as well as Microsoft certified professional. So we are going to, I am going to take first part of the session, that is the theory or the conceptual discussion. Then Nitanshu will drive us through the practical or the from the demo point of view. So let's go ahead, and before we start the session, we just want to just share a few information about Azure free exam vouchers that we are going to give to few participant. So for that, you need to participate in the quiz, which will be there in the last of the session. So we'll be having a quiz just like previously we had. And today, during before we will have the quiz for today, we will also announce the winner of the previous session quiz, and those winners will be getting the Azure exam vouchers, free as Azure exam vouchers, and using that they can appear for any exam free of cost. Six participant we will be selecting, and then there is one condition that you should be participating in the quiz, as well as you should be registered on Eventbrite page that we have for the session. So we will be matching those people who are also registered there, and then we will be picking few of the people who will be getting Azure passes. Winner will be announced for today's session. Winners will be announced in the next session. And today we are going to announce the previous session winners. So that is the format of this quiz, and that is how we are going to give away the vouchers. Now let's go ahead and understand this DevOps exam AZ-400. For appearing for to get the certification, uh, you can go ahead and take the exam that we are for which we are having the training, that is designing and implementing Microsoft DevOps solutions, which is exam 400. But to get a certification badge, you have to have one of the prerequisite. Either you should be a certified administrator, that is the first exam AZ-104, or you should have a developer associate certification, which is AZ-204. If you combine any one of them and with the AZ-400, then you get the certification badge, which is Microsoft Certified DevOps Engineer. So we are going to have the AZ-400 discussion, but and you can appear for the exam, but just for the from the certification or from the badge point of view, you should also have to have one of the exam cleared, that is AZ-104 or AZ-204, so that you can combine this all and then you can be eligible for the DevOps certificate. We have conducted AZ-104 training. So if you go through our YouTube channel, and we have hosted the session and then recorded the session, and that is there on the YouTube channel. So you can go there and you can watch all the sessions. And a couple of people, many people have actually just enrolled for exam and passed those exams after watching our sessions, and they have kind of acknowledged that particular information. So you can go there and watch the training, and then you can also appear for one of the prerequisite. Now let's go ahead and discuss about some prerequisite here. So, the agenda of this exam AZ-400. In this exam, these are the modules that you need to cover from the from the uh, the topic point of view. The first topic is facilitate communication and collaboration. The second is manage source control. So these are the two modules that we have already covered in our previous session, and we have also shared the session recording on our YouTube channel. So you can go there and watch the recordings if you have not watched our previous session. After that, this is the today's agenda, that is define and implement continuous integration. This particular topic contains one of the largest weightage of your exam, that is 20 to 25%. So that is the reason we tried to divided this session into two parts, and the first part we are going to have today, and the second part we will be having in the next session. So, and then in upcoming sessions we will be covering the other modules that are part of this exam. Now let's come back to the agenda of today's session. The first thing that we are going to discuss about is design build automation. So we will talk about how do you design your automate, what exactly the build is and how you can design the automation around it, and why you should do that. Then we will be talking about the build strategy. So what are the various aspect or practices or the or the design patterns that you should be aware while you are implementing the build strategy in your organization. Then we'll be talking about the maintaining that build strategy. So implementing build strategy is one thing, and then how you can make sure that those things are working properly, they are maintained properly, they the people are updating it as and when their things are changing. So that is the thing we are going to discuss about. And then in the last part, we will be talking about how do you design a process so that you can standardize those implementation, those maintenance aspect across the organization. So what are the things are there, what are the tools are there, what are the best practices are there, so that whenever you do some proof of concept for implementing a build strategy or looking into the maintenance part of it, then how you can standardize it within your organization. So let's go ahead and discuss about the first section, which is design build automation. Now, when you design your build automation, and actually when you want to run a build in your organization, there are certain things that you need to look at. The first thing you will be looking into is code analysis part of it. So when you are running a build, you want to make sure that whatever the known coding standards are, whatever the known security vulnerability may be happening because one type of platform that you are using to develop your application. What are the best practices from the ecosystem? So suppose you are working on .NET application, or you are working on from the infrastructure point of view. If you are working on something called ARM template. So what are the basic things you should be consider when you are developing your code? How do you scan your code? How do you look at this from the best practices point of view? How do you look at it from the security vulnerability point of view? So all those things will be part of your code analysis part. So when you are building your build app, when you are defining your build, then this is the first thing you will be looking at. Then the next thing that you will be looking at is dependency scanning. So when you are building an application, probably a .NET application, then you would be looking at what are the packages. For example, in .NET, there are packages, there are NuGet packages that might be part of your project, which might be coming from open source world, or which might be coming from internal organizations. So what are the various things are there, and what are the dependencies are there, and if at all those dependencies are secure enough, if at all those dependencies are maintained enough, that can be allowed in a build of your application that is coming from that is for your organizational application development platform. So suppose you are developing an application in within your organization, and developer has used a dependency NuGet package which is open source, and suppose that particular open source package is not well maintained, right? And if at all you are not looking at that particular aspect, then what will happen? Developer will be able to implement those features which are which are being asked to him to implement using those dependencies, which using those open source packages. But if that package is not maintained properly, all right, and you cannot control that aspect because that is coming from outside of your organization, then what will happen? Whatever the vulnerability will be happening on that package level will be part of your application as well, because your application is a dependent on that particular package. So that is the reason you should be looking at dependency scanning. How you can look at this? There are various tools. There are various static code analyzers, or there are various scanning tool which can help you to scan the dependencies. Then the third thing, which is very important from the build point of view, is running your test. Whether it is, we will be talking about testing strategy in one of the upcoming slide. But what do we mean by test is it can be any kind of test. It can be unit test, it can be integration test, it can be any kind of test that must be happening while building your application. So those tests, if they are not passing, those tests which are not passing, and because of that there might be a breaking change into the application, then you should be catching those particular things using testing strategy. So we will be looking at it, that what are the tests you can automate, what are the tests you might not be able to automate, and you might not be able to put it into the build pipeline. You might have to look at some other way of catching those problems using testing strategy. So we'll be looking into it. But when you are looking at your build, you should be looking at what kind of things that can be tested, so that if at all things are passing from the build, they should be sure enough will be running on your system. Now the next thing is compile. Definitely this is what you do normally on your local computer as well. So when you are running a .NET application, when you're running a Java application, when any application which is a compiled
app which is developed based on a compiled platform, that is .NET, Java, and all those things, then you must be compiling them so that you get a valid DLL file or the valid exe file or a valid MSI file or whatever format it may have, and then you can go ahead and give it to the deployment team, and they can deploy it on the server, on the desktop, or wherever it is supposed to be deployed. So compilation is the one is another thing that you will be doing. Now before you do the compilation, you also look at the configuration changes. So if at all, suppose your developer has moved the code, and then developer, you might be giving a different environment to the developer to do the development. For example, you might be giving a different connection string to the developer while he is developing, and you might want to change that connection string during the build process, so that when the package which is coming out of that particular build process does not have that particular development environment linkage, rather it should have production, or production or QA or whatever the next environment is, that environment information is there. So that kind of configuration changes. Or maybe suppose you are you are building an application, and that might have a dependency with one of the infrastructure property. Suppose you are deploying an application which needs a particular features to be enabled on the infrastructure side, then in that case you might want to change that particular configuration before you build your application, so that when the next step of testing happens, that particular change is in place, and that way you will be able to make sure that things are there, all those configuration are corrected and changed before passing the build pipeline. So this is the these are the one of the major sections or major points that you will be looking at when you are building your whenever you are kind of designing your build pipeline or defining your build pipeline. These are the major things that you will be looking at when you are defining your build pipeline. Normally what happens is that you have code changes, you have a version control system, that is Git, or any other version control, but Git is one of the most popular Git version control system these days. So suppose you have a Git version control system, you will be having a code review process. We have talked about code review and all in one of our previous session, where we have discussed about managing source control system. So if you are not familiar with this particular aspect, I will definitely recommend you to go there in this previous session and look at what are the various ways you can implement your code review process. Whenever there is a change, you will be having a code review process where peers will be reviewing the code, and they will be looking at it in a very collaborative manner, that the what are the things which are as per the standard, what are the things that can be reviewed further and can be changed and all. Once the review is done, then you will be having a build pipeline. Now in the build pipeline itself, we have discussed one of the thing that you do is code analysis. So your code analysis will be happening, and based on that code analysis, you will be having a reporting kind of thing, that okay, these are things happening, these are the tests are passing, these are the tests failing, these are the dependencies, these are the package dependencies, these are the open source package dependency, these are the internal package dependency, all of these. And based on that, you define a quality gate, right? So based on that code analysis, you define that okay, if there is some tests which are failing, and they fall into that particular category, all right, I am not going to pass that as a build. That can be there. Or it might be that there might be some low priority testing or low priority, code vulnerability that you might want to skip for your build, based on your organizational standard, based on your understanding of that particular level of risk or that particular level of technical depth that might happen if at all you will allow those low priority things. You based on that, you define a quality gate, and that's what we call quality gate. Based on that, what can go, what cannot go, what are the priority, what are those things, you can define all those things. And if at all that quality gate is passing, then you get something called artifact. Artifact is something which comes out of your build infrastructure. When you do the build definition, we will be talking about what are the various things you do in the build definition. But when you do all those things, out of it, when it comes a exe file, a jpeg, sorry, the zip file, or a var file, or whatever, I mean, a zar file, whatever it may be. It entirely depends the type of the, the stack that you are building, the type of application you are interacting with. But end of the day, when your build passes, it generates a package or something that can be deployed. That something, that particular thing is called artifact. It can be a zip file, it can be a exe file, it can be a msi file, it can be a, it can be any file that can be given to the other system, either it is manual or automated. That, okay boss, things are fine, tests are done, everything is done, build is passing, you can go ahead and deploy it. That's how your quality gate defines whether this should go out or whether this should not go out. If at all your quality gate is not passing that, your artifact will not be generated. Then and there you will stop it, and then your code, it will go back to your code developer, and then they will have to review that, if at all they should be allowing that particular quality gate, or they should be making those corrections so that quality gate can pass and then generate the artifact. Now, the next thing we will be talking, once you have this quality, inspection, and you might be having certain things which you can automate, and certain things you might have to do manually. Now, based on that particular thing, we have something called testing strategy. And in this strategy, we divide all these types of tests into 4 quadrant. As you can see on the image, we have a rectangle, there are 4 quadrants are there. Now, in this 4 quadrant, on each edge, we have something called, let me just give me a moment. Okay, so on these quadrants, you have something called these uh, these technology facing, these are supporting the team, these are critic the product, and these are the business facing. So based on the facing side, they can be either technology facing or they can be on the business facing. What do we mean by that is that the types of test you are writing, they can be either biased towards technology. It is more of like writing script, running the script, getting the details from the script, script result, finding out whether this was passed based on the code, based on the HTTP response code, or based on a particular type of output that it generates. Those are called technology facing. Or it might be business facing, facing, where you will be not concerned when you are running those types of tests. You might not be concerned about technological, more concerned about the technological aspect, but it will be more on the functional aspect, what business is looking at. You might be looking at the functional aspect of it. Similarly, there might be few tests which are supporting the team. So what do you mean by that is they are telling that these are the tests which can improve your product, which are not breaking changes, I mean, which are not breaking tests, but they are kind of additional feedback about your product. But there can be certain tests which can be critical to your product, where the feedback from the testing will come as a negative point of your product, and you have to improve on it. So based on these 4 sides, we have these 4 quadrant. And the first thing that falls into the first quadrant, which is there, you know that is called unit test and component test. They are mostly technological test. You write unit test in a particular programming language like C sharp, or I mean, based on your programming stack. They are like a programs which runs and then finds out things are happening properly, those units are executed properly, the information is coming properly, and all those things. So unit test. Similarly, you have component test. Those components are, those things run a script, a function, or something which can be more on the technological side, that can be automated. So based on type of these tests, we have enough uh, technology for various platforms which can help you to automate these kind of tests. But if you go towards quadrant 2, these are the functional test, story test, prototype test, or simulations, where it is not entirely based on some script. It is more on the side of looking at the color, looking at the functional functional side of it. You might be looking at the graphical user interface. You might be looking at whether if I click on certain button, if it gives up a desired result or not, if the functions are properly, if they are giving the results in a proper format, if they are, all those kind of tests, they which are falling into these types of tests. Those tests either can be automated or manual. So they, based on the types, if, as you may heard, that there are certain graphical user interface tools which can help you to do the functional test or the graphical user interface test using automated tool. But there are certain types of tests which are functional in nature and might not be able to automate them. So these types of tests, you have to design your strategy in a way that you have to compromise in some places where they cannot be automated, hence they cannot be put into your build cycle. And that's why you have to put a particular QA team or a QA stage where certain manual efforts will be required, so that they can do the enough testing, and then they can only promote the build to the next phase. Now, the quadrant 3 can have exploratory tests, scenario usability test, and all. These tests are also business facing, all right, but mostly manual. It is like, they usability testing. So you might, or user acceptance testing. These tests are mostly, based on the user feedback, based on the person to person and interpretation of the features and all those things, where business comes into picture and tells that, okay, what do we mean by that feature, and how our people are going to use that particular feature. And based on that manual inspection, we might be able to tell that whether these things are, working as expected or not. Similarly, in the later, the last quadrant, that has performance load, security test, ILT test. These testings, as as you can see, these testing can be, based on the tooling side. You can have a load testing tool, you can have a performance testing tool, and then you can implement those tools, and can be automated, can have the script or can have the tool do that work for you. So based on these understanding, you have to define your testing strategy, and based on that particular testing strategy, you will be looking at your build to incorporate certain things as an automated way of doing things, and you may have to look at certain things where you have to do some manual stuff till the time it does not fall into other quadrant where things can be automated. So this is the, testing strategy you can think of when you are implementing your build, and when you are looking into what are the things I can put, what are the tests I can put into the build, and what are the tests which might not be, which falls into a category where, they fall into business facing area where manual things will be required. Now, after understanding all these things, you will be looking at, implementing your build strategy. So you know that, okay, these are the things we automate, these are the things we cannot automate, these are the things we are going to check, these are the things we are going to change during the build, build. These are the things that we are going to run, the quality gate against. So all those things are, you have verified, okay, these are the configuration changes you are going to do in terms of infrastructure, these are the configuration changes you are going to do in terms of application code. After understanding everything, then you look at the, the how do you implement those things, using some tools, using some, the process which are there based on the tooling or based on the requirement that you have. The first thing that you will be looking at, having a build infrastructure. Of course, when you are looking at building your, when you want to automate your build, you have to look at certain tools which are available in the market that can help you to do that particular build, build automated build, CI pipeline, and all those things. So the first thing you will be looking at build infrastructure, and the first thing that you will be hitting towards is what tool you can pick. So there are various tools. We have listed down few of the most most important or most popular one. If you talk about AZ-400 questions point of view, these are the three major tools where questions might be coming around these tools. Azure Pipeline, which is coming from the Microsoft Azure DevOps Services, GitHub Actions, which is again a part of GitHub solution, which is again now acquired by Microsoft. So somehow it is again coming from Microsoft itself. Then there is a third tool which is quite popular, that is Jenkins, which is an open source tool that also helps you to build your infrastructure in terms of build pipeline. Now, when you look at these tools, and there are so many other tools which are there, and you might have to look at those tools as well, based on your need, based on your organizational need, based on your organization approach towards a vendor. So all those things will come into picture. But when you are looking at various tools to implement the build infrastructure, the first thing which will hit you is cost. So what is the cost for that application, for that particular of that particular tool? So if we are talking about Azure pipelines, so Azure pipelines is free for 5 users. So and of course it is free for open source project. You have certain number of 1800 minutes of free per month build minutes. You have hosted agent and all those things. So Azure pipelines is one of the thing that can help you to start without investing anything. Similarly, GitHub Actions is also a similar options you have, where you can start working on GitHub to build your CI pipeline. And if you are running a open source project, then it is almost free for you. And if you are running an on-prem solution, if you are running if you need it for your organizational need, of course there will be a pricing that you have to go through based on the GitHub documentation. But of course it also has a free tier similar to Azure pipeline, similar to limitation will also have similar to what you have with Azure pipeline. Now when we talk about open source software, that is Jenkins. Jenkins comes free as a download, so you can download it. But the thing is, Jenkins is just a software. You do not have the infrastructure, unlike Azure Pipelines or GitHub Actions. So GitHub Actions or Azure Pipelines are software as a service solutions. They are hosted by Microsoft or GitHub, and then they are providing you a basic level of services free of cost. In case of Jenkins, you have to implement your server infrastructure to host this application. So from the application point of view, it comes free, but you have to have the infrastructure so that you can install this one, you can configure that particular infrastructure, and then only you can use it. There are certain vendors who are giving Jenkins as a free solution on their infrastructure for a certain limit. But in and all, if you are talking about enterprise, you have to kind of download it and you have to set up your infrastructure. So in that sense, if you're just starting up, Azure pipelines and GitHub Actions are making sense, and that's how the exam also kind of expects. But to know Azure pipelines and GitHub. But at the same time, Jenkins is one of the most popular tool for CI implementation in open source world. So you must be looking at this one from the point of view where organizations do have this particular tool. Now, when you are talking about Azure pipelines, GitHub Actions, or Jenkins, except Jenkins, you will have the option of hosted agent. Now, what is hosted agent? So hosted agents are when you are running your build pipeline, it must be running on a particular, on a server, on a compute, on a computer, on a virtual machine. Now, in case of Azure pipelines and in Azure pipelines and GitHub Actions, Microsoft or GitHub provides you a certain level of compute free of cost, and after that they will have a tier where they will provide you that same virtual machine, compute, or whatever you may call, with a costing mechanism. So they will have a free limit. So in case of Azure pipeline, it is 1800 minutes. So if you're running your build, you can run 1800 minutes of build every month free of cost for any project, private, public, whatever. But in case of Azure pipeline, if you are running a private project, public project or open source project, you will have unlimited time, not 1800 limit. So you, for open source project, Azure pipeline can help you with running builds for unlimited time. But if you're running it on premise, in an organization for a private project, then you will have a limit of 1800 minutes. After 1800 minutes, you will have to pay a certain amount to Microsoft if at all you want to use their hosted agent. That's why the name is hosted agent, where it is hosted in Microsoft infrastructure, and primarily it is hosted in Azure, which is Microsoft Cloud. Similarly, GitHub is also providing similar kind of already hosted infrastructure, where if you configure your CI pipeline in GitHub Actions, then it will run in a hosted infrastructure, and they will not charge you for a certain limit. After that, they will be charging you. So there is a payment. You have to figure out how many things are there, how many builds I'm going to run. Is it going to cross 1800 minutes of limitation that you have on Azure pipeline? Similar kind of thing. If at all you have a consideration where you don't want to buy their server, I mean you don't want to go with the hosted agent, either because of your organizational security aspect, where they cannot run the build on a server where they do not have control, then in that case you have something called private agent, where you can have your server in your on-premises system or in a virtual network in a cloud. So you can have anywhere. It can be a virtual machine in a cloud, it can be virtual machine on premises, anywhere. Then you can connect that particular private agent with Azure pipelines or GitHub or Jenkins, and then whenever you are running the build using one of the tool, Azure pipelines or any one of the CI pipeline, the build will run on that private agent. So the execution will happening on your own server. So you can see what are the what are the artifacts are getting generated, what are the log files, what are the things are happening. All those things will be available to you. And even if your organization permits, you can go there and look into the agent and troubleshoot things and all, which is not available in hosted agent. Microsoft giving you a compute to run your build, but they will not give you RDP access and all those things, which might be needed in some scenarios where you want to configure your private your agent with certain toolings, with certain packages, with certain runtime, so that your build can progress properly. So this is the reason you might want to look at the private agent, and you will have to plan your private agent infrastructure properly. So based on the runtime that you need, based on the packages that you need, and all those things. Now, once you have all these things consideration in in your planning, that okay, these are the things that I will need, then you go through the implementing your build pipeline. Now when you implement your build pipeline, the first thing which comes into picture is CI triggers. Now CI trigger is also known as continuous integration triggers. So what do we mean by here is that normally you have your version control, which is hosting your codes, and whenever something changes, those changes can trigger a build. Now that trigger that you can define in based on tool, and during our demonstration we will be looking at Azure DevOps, where do you define that trigger. So these triggers, what do you mean by these triggers is that based on changes in the code, in a branch, in a schedule, on a path, on a tag, it can start a build. So if it is happening on a branch, then only it will start a build. You can define that. So suppose in a version control, you normally have various branches like master, develop, release, and all those things. Now, if at all you think that I only want to start the build when there is a change in master branch, all right, develop, I don't want to run the build. Any other branch, I don't want to run the build. Just a hypothetical example, in real scenario, you might want to run the build for each branch, each main branch, develop, release, or master. You might not want to run a build on a feature branch, but you might want to run a build on every main branch. So you can define that, or you can define a schedule. So your developers are working all the day, and then because your builds are complex, this is going to run for 1 hour or 30 minutes, or it is going to take a lot of compute, or it is going to run it is going to need a lot of resources. Then you might not want to run on each change. You might want to let the developer do all those changes into that branch, and you might want to run the build on a particular schedule only, right? Every day in the night, every day in the 10 p.m. in the night, where no developer is working, or maybe every day in the starting the work of the day, like morning, early morning. That kind of a schedule you can define. Similarly, you can define path as well. So in your version control system, you might be having various folders. Within each folder, you might be having certain code or certain files which might not be requiring a build. Right, so for example, web.config file changes, they do not require a build, right? I mean, web.config file does not require a build at all. It is not a compile code. Similarly, in the same repository, you might be having some other files which might not be part of the application build process, and you might not want to run the build, or you might be having a single folder which is containing the application code, and other folders are containing documents or other things. So you might want to configure your CI pipeline to trigger the build only when there is a change in a particular path. So that particular thing can be done. Similarly, in version control system, you have tags. So when you define your build with a particular tag, then only define your changes with a particular tag, then only it should start that build. That can be also done. So there are various trigger filters that you can define, and based on that you can run your build. Now, as we have discussed, there are various things you might be running in the build. Based on all those things that you are incorporating in your build definition, there will be a success, and after success you will be getting a answer. This is what going to happen on each change, based on a branch, based on a schedule, based on a path, or based on a tags. Now when you define your build, we have already discussed that you might be having the build cycle. Now what do you mean by this build pipeline? When you define your build pipeline, like similarly you have a trigger. Now after trigger in a build, you can have various things running. One of the things that you will be doing, as we have discussed, testing. You might be incorporating all those things which are to be included as an automated testing feature, like unit testing, integration testing, API testing, all those kind of things. Whatever you think can be integrated to validate if this build is functional, if this is going to really if this is going to build a thing which will be able to run on a server, or on a or is usable. You might want to look at the package dependency. We have also discussed about that. In your application, you might be having various packages involved, and then when you are defining your build definition, you will be looking into restoring those packages. For example, in .NET, you will be restoring the nuketed packages. In other development ecosystem, you will be restoring the packages based on that particular development ecosystem. So you want to kind of look at all those package dependency. You want to scan those packages. If at all there are certain open source packages, there are certain packages with vulnerability. Based on the tier of vulnerability, you might want to define your quality gate. We have already discussed what is quality gate. So all those things you will be defining. You might be changing the configuration. We have again discussed about that. You might be changing the connection string. You might be changing the some variables. You might be changing some environment variable. You might be picking some variables from some other ecosystem. You might be taking a secret information like password from the Azure key vault. So all those things you will be making changes into the configuration changes, and then in the end you will be compiling. So when you are done with all the types of tests that you are supposed to run, when you are done with all the types of configuration changes that's supposed to happen as a part of that build, when everything is done, then you might be running your compile that is going to generate your build artifact. And that is how you define your build definition. We will be looking into the build definition during our demonstration lab part, where Nitanshu will be showing you how a build looks like in Azure, Azure pipelines. But these are the major things that you will be taking care. Now, based on the platform, based on the software that you are building, there might be certain other things you might want to do, based on those needs in your build cycle itself. But these are the high level things, these are the high level sections that are applicable in majority build definitions that you want to run in your build pipelines. Now, when you look at the configuration, we have discussed about configuration changes, and that happens, quite a lot time. When you are looking at configuration changes, so what are the things that you might be looking at? You might be looking at the DB connection string. So you have an application. That application has a database connection, which supposed to happen to to make this application run. So that particular database connection, from when it is committed by developer, that might have a developer specific database connection string. You might want to replace that with the actual database connection string, or you might want to remove it and then take care of that particular connection on the deployment server itself. So whatever you want to do, you want to make those changes, because when you do the build cycle and whatever comes out of that build cycle, you should not make changes into code post that. So once you have the artifact, those artifacts should be deployed as it is. You should not be making any code changes into an artifact. So if you are not replacing your connection string, and if you are not replacing your connection string during the build, and suppose you have generated your artifacts with a connection string, which is a developer connection string, and then your deployment team is changing that connection string, that the from the artifact that you have given, which is coming out of your build pipeline, which is not a correct best practices, which is not a right way of dealing with artifact. So if at all there is something which is being changed by deployment team in the code, then that has to be communicated back to the the person who is building the build pipeline, and that person should take care of those changes. Similar to that, this kind of scenario can happen for application variable. This can be system variable. This can be secrets like password, like connection string, like other information, API, secrets, or certain certain values that's supposed to be there, so that the application can talk to a third party system. Those things you need to take care during the build pipeline itself, so that you can change those things during that time. Then you will look at infrastructure configuration as well. So when you are building your application, and if at all you are also building infrastructure part of that, right? So suppose you have a web application, you are developing your application and then deploying the web application into Azure web app. All right. Now, the Azure web app deployment is also supposed to happen through the pipeline process, like CI pipeline. Now, if at all your application has some changes, which is going to expect some changes on the infrastructure side, or maybe it's supposed to deploy the infrastructure as well as a part of that particular deployment. So you should make sure that if at all some configuration changes are required, or if at all certain infrastructure is supposed to be ready before this build can go and hit that hit that particular infrastructure for deployment, you might want to do that during your build, looking during your build definition, or maybe just after build you can run another build which is going to make changes into the infrastructure or deploy the infrastructure. That particular option is also available. We will be talking about where it is in the Azure pipelines. So there is an option where you can trigger a build just after one build. So you can trigger a build just after once your application build is configured, successful, then you can trigger another build, or once your infrastructure build is successful, then you can trigger another build which is going to build the application for that particular infrastructure, or vice versa, based on your requirement. But this is also one of the things that you should understand from the build definition point of view. Now comes the next part, which is maintaining the build. So once you have the build infrastructure with all these things in picture, right, you have your infrastructure pipeline, you have your application pipeline, you have taken care of your application code dependency, you have taken care of all those things, then you might want to maintain that particular thing, so that whatever you have done, whatever build infrastructure you have built, whatever the tool selections you have made, whatever the testing strategy you have picked, you have to maintain that as well, so that tomorrow things can improve over period, right? DevOps is all about improvement. So today your build is taking like 30 minutes or 40 minutes of time, it is possible to reduce it further to 20 minutes, and then further to 10 minutes, and you know or maybe some other task needs to be added so that things can work with the features that are being included. Suppose now developers are using new packages which may have a dependency on the infrastructure, or now developer is using a new feature where they might need another infrastructure to be created, or certain things needs to be done. All those things will only be you will be able to do if at all you are maintaining your build. Now, what are the things that you need to look at when you are talking about maintaining your build infrastructure? The first thing that you need to look at is pipeline health. Now, what do we mean by pipeline health is? The first thing is that you should recognize flaky tests. Now, what are flaky tests? Flaky tests are certain tests which are kind of those tests where there are certain tests in infrastructure in your build where sometimes they pass, sometimes they may fail, because of, suppose you have a test to check a API, okay, during your build definition itself. Now that API is not a highly available solution, right? So it might be possible that particular API sometime is available, sometime that API is not available. And when it is not available, and if at all that time your build is running and running that API test, that API test will be failing, and that way your tests are failing in the build definition. This is one example. So sometime that API test will fail, and then you will be thinking that okay, my builds are failing, and then all of the sudden if you are running it again in the next 1 minute, API is up and running in the background and your tests are passing. So those types of tests are called flaky test, and you should recognize such flaky tests which are making your pipeline health, which are impacting your pipeline health. So 70% of the time it was passed, 30% it failed, and then in those 30%, 20% of the time it was because of one particular test which is very unpredictable in nature. Sometimes it passes, sometimes it fails because of certain dependency. So you need to recognize those dependencies, and you need to either take out those dependency, or you need to automate that test in a way that it should not remain flaky for the longer time. You need to monitor the pipeline execution, right? So to recognize the flaky test, you can only recognize that flaky test only if you are monitoring the pipeline, how much time it is taking, if it is normal to run this build for 30 minutes. Is it something I need to take care? Is it like is it some task in the build pipeline which is unnecessarily taking 5 minutes of your time, which might be removed, or which might be replaced by a different task which can be finished within less time, 1 minute or something. So if you will monitor your pipeline, you will evaluate, even though builds are passing, but how much time it is taking, how many tests are passing, how many tests are failing, are there any flaky tests? If they are flaky, then can we fix it? How can we fix it? Those kind of you know decision, those kind of understanding you need to understand, and then only you will be able to kind of improve your pipeline health over period of time. The next thing is analyze failure rate. We have already discussed about the monitoring pipeline. So monitoring pipeline will end up giving you a data where you can see that okay, these are the things which are happening. And the good thing about Azure pipelines in general, if you look at the tooling point of view, Azure pipeline does expose lot of data, and then it gives further integration with Power BI, which is one of the analytic solutions from Microsoft. And then you can actually analyze that data, using those dashboard kind of solutions, which can give you more insight about your pipelines, or or anything that you are doing in your Azure DevOps, uh, that how things are going, and if at all you can improve those things, including pipelines. So if pipelines are taking too much time, if you are using so much hosted agent time, can you replace it with the with the private agent? Can it be done in a better way? Can you upgrade your hosted agent or private agent? Can you do it with better task management? On all those things, you will be able to analyze, if you are monitoring your pipeline, and then you are making use of that data that is coming from the monitoring point of view. Now, once you have these data, once you are able to understand your pipeline health, based on the flaky test, based on your monitoring pipeline, based on your analysis that you have done, either from the Azure DevOps pipeline interface itself, and or if at all you have so much data, if your team is really using so many builds, then if at all you are integrating with Azure other systems like Power BI, then you will be getting a lot of information about improvement. And there are certain things that you might want to take, which can improve your pipeline pipeline infrastructure in the organization. And the first thing that can improve the pipeline infrastructure is pipeline templates. Now, what exactly the pipeline templates are? When you are working in Azure DevOps, I mean Azure pipelines for to be specific, then there are two options that you can do. One is when you can build your pipeline using a graphical user interface. That is similar. If you are coming from a Azure background, then it is very much similar to your Azure portal. You go there, you look at the things, you click on it, you create that infrastructure. No coding knowledge is required, nothing is required, you just do it. But as you may know, if you're coming from Azure in background or any other cloud background, then it is very difficult to automate that way of operations. You cannot really automate, if at all you are doing things entirely with with the portal. The And then comes the things which are called, in terms of cloud, it is called infrastructure as code. Similarly, in in the pipeline world, in the build tools, today there are concepts called pipeline as code, where these pipeline applications, build applications like Azure pipelines, Jenkins, or GitHub Actions, gives you a way to write your pipeline as a code. And to be very specific, Azure Pipelines gives you a way to write your pipeline as a YAML file, YAML, YAML file, and that way you can manage your pipeline as a code. Now, when you manage your pipeline as a code, that definitely increase the reusability aspect of your pipeline, because when you are using a code to do certain things, definitely you can share that particular code to other person, and with minimal changes they can reuse the same template or the same thing into their infrastructure. To improve it further, Microsoft, this Azure pipelines and other pipeline tools as well, they have concept of templates. So you can create a template, all right, and using that template, you can actually standardize your what you call build infrastructure or build definitions across organization. So suppose in your organization, they do build a lot of software that are based on ASP.NET. All right, so you can build a template which can define all the standard task that has to be followed in your organization to build a .NET application, and then you can release that particular template in your organization. And then later on, whenever someone wants to build a build pipeline or a pipeline, they don't really have to work from the scratch. They will just pick that template and then start using it and run the build. And that way it will be sure enough that you are using the company standard or the organization standard task. So tomorrow if your build pipeline is passing but deployment team is saying that okay, this is not ensuring this particular task has run during the build because it is failing on this, this particular component is not there. So for example, in your organization it is a standard task that you are going to restore your NuGet project, I mean NuGet packages, or you are supposed to replace the connection string in your ASP.NET application. And if at all you have not taken care of it, then later on, your release team can come across and they will say, okay, your build definition is not a standard one. You do not have a ABC task that is a standard task in our organization. So to escape, I mean to actually save you from there, pipeline templates will help you. And in Azure pipelines or other software, I mean other ecosystem, you have a concept where you can develop a template and you can release it in your organization and they can further use it to implement a standard process to develop the pipeline. The second thing which is very similar to that, but it is kind of very important, where you can have common variables and task groups. So if at all there are templates to standardize the complete build definition, but there can be there might be scenarios where you might not want to standardize the whole template, but you want to reuse certain variables. Like you might want to have a naming convention for artifacts. You might want to have a naming convention or a particular security string for a particular things which are happening in the build definition. You might want to have a particular type of certain setting that needs to be set during the build definition. All those things, standard information, standard variables, you can define as a group variable which is available in the Azure DevOps. And then people can start using those variables without exposing the values those variables having. So for example, you might have a database string that you want to everyone use during their build process, that has to be replaced during the deployment pipeline, which is a, a shared instance of database and or whatever. Now that value you don't want to share. You just want to tell them that okay, this is the value that you need to, this is the variable that you want to use, and then automatically it will be taken care from a global variable group where it will be exported and then that will be used. So that kind of implementation you can do with the common variable task or the group variable. And then there is something called task group. You 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 know similar to pipeline templates, in pipeline templates what you have is that entire pipeline you are standardizing. So in pipeline, suppose you are having a pipeline, okay, and you are standardizing the whole pipeline. Now in some cases it might happen that you do not want to standardize the whole thing. You just want to standardize these two things, all right, these two tasks, task 1 and task 2. So in Azure pipelines there is a way to kind of create a group of this task 1, task 2, and you can call it task group 1 or something. And then in a next pipeline, suppose where you want to use this task 1 and task 2, instead of using task 1 and task 2, you will just use task group 1, task group 1, and automatically it will use these two tasks and it will automatically do the work. And then other things you can do. So you might not want to use the entire pipeline, but you want to use a certain task collection of tasks from one of the pipeline. For that you can use task group, and that is how you can kind of standardize, you can kind of improve your reusability aspect, you can improve, sorry, you can improve the pipelines in your infrastructure from the reusability point of view, from the standardizing point of view, and all those things. Now the next thing, which is build time, which is a very important aspect when you analyze your builds. All right, let me, when you standardize your build, when you look at the builds, and when certain types of builds are happening again and again, your build infrastructure which is having your compute, maybe your private agent, that is a virtual machine in Azure, and you might want to save some time there, right? So suppose you have a task like task one. Okay, task one is taking like 5 minutes, and then task two is taking like 1 minute. Okay, and then task three is taking like another 15 minutes. I'm just giving an example. In total you have like 15, 5, 20, 21, 21 minutes, 21 minutes of build. Now if you are looking at data, then you might understood that okay, task 3 is taking too much time, it should not take 15 minutes, there must be something I can do about it. And then based on that, you might want to reduce it from 21 to maybe 18 minutes, or maybe 10 minutes, based on the need, right? You can only look at it when you, and then the moment you will reduce it, it will automatically save your few minutes from the build infrastructure. And if at all this build is happening on an Azure VM, okay, if it is happening on Azure VN, and the amount of time you are saving, it is a save for your cost as well. So that way it is not only standardizing your build, but it also saves your cost from the build infrastructure point of view. Most of the organizations these days will be executing their build on a cloud infrastructure, and cloud is like on demand kind of thing, right? So as and when you need it, you spin it and you use it, and then you destroy it. The amount of time you are using it, you are paying for that. And if at all you are able to reduce that time, then you are optimizing your code, at the same time you are reducing the cost for running that build. And that is why when you are looking at the improvement or your pipeline, you should look at the build time. Another is pipelines code. We have already discussed that pipeline templates are the way to use. And then to use the pipeline templates, you have to look at the pipeline as a code concept, where you can use YAML app, YAML file to define your pipeline. And that is the way you can implement your pipeline, you can improve your pipeline. Now when you look at your pipeline maintenance, the another aspect that you should be looking at is build agent capacity. Now when you look at build agent capacity, we have already discussed that to run a build, you need, you can define your build definition. All right, you have a build definition which runs certain tasks, task 1, task 2, task 3, task 4, task 5. Now all these things will be executed on some server, some VM. It can be a hosted VM, which is Azure VM. Hosted agent means a free VM from Microsoft for 1800 minutes for private project, unlimited from the for the open source project. Now this VM is something we called as a build agent. Now if at all this build agent is your host, is a private agent, which is your on-prem VM. Private on-prem, it can be on-prem or it can be in your own Azure cloud virtual network. So if it is a virtual private VM, then you need to look at the compute and memory of this VM, because your build are going to run on this particular virtual machine. And if at all you have spin up a small size VM, and then your build requires a little bit larger size of VM, like more CPU, more memory, then your build will start either failing, or it may not finish in a expected time. So to either, and then vice versa as well. So suppose you have deployed a quite a bulk VM in terms of size, like 16 CPU, 16 virtual CPU, and then suppose 32 GB RAM or something like that. And if at all you are just using it to running a build which is going to utilize just one CPU or less than one CPU, one vCPU, and less than 1 GB RAM or 2 GB RAM, then all of those are extra uh, resources that are available with your build agent are waste, and you are paying for it. So from both from the cost point of view, from the optimization point of view, you should look at build agent capacity, the first thing. Second thing you will be looking at is runtime and other dependencies. So since you are managing this VM, all right, you are managing this VM, you are kind of running your build on this. Now, suppose you are running a build which requires a particular PowerShell module on the build agent. So suppose as part of your build, you are running a PowerShell command to yeah, kind of doing certain things during your build definition. Now that command will be executed on this VM. Now, as you know, if you are running a PowerShell command, and if it is a custom PowerShell, I mean a PowerShell commandlet from a particular module, for example, SQL Server, for example, Azure. If at all that is coming from a specific module, then you have to get installed that module in advance here. Then only that particular command will run as a part of your build definition. Other, apart from that also, suppose you are running an application which needs PowerShell .NET Core to run the build. Now, .NET Core is not the standard version that comes with the some operating system like Ubuntu runtime and all, or maybe on Windows as well. So on certain versions, you have a standard .NET framework, full .NET framework, but Core is not available by default. So you might have to install those dependencies, install those runtimes if at all your build needs. So you need to look at those aspects if at all you are setting up your build capacity, your build agent. Then both from the compute and memory point of view, both from the app and also from the application installed application, installed runtime point of view. Now the third thing which is very important is parallel jobs. Now what is parallel jobs is that since you are using, yeah, since you are using this one VM, suppose, and it is linked to Azure pipelines, right? So this is your Azure pipelines. Now in Azure pipelines you might be having different build definitions, like build one, build two, and then suppose there is another build 3. These are three different build definitions being used by different teams. This is .NET team, this is Java team, this is another .NET team. Now it might be happening that while B1 team, okay, while they are running their build definition on this particular app server, build server, another team which is B2 might be also initiating a build, build, or maybe another team which is B3 is also initiating a build. Now in this case, this is what we call parallel jobs. So in this particular VM should be capable enough to run parallel jobs, parallel builds at its time, if at all that is required. If these teams can wait for some time to B1 to finish, that's fine. But in organization, you might want to save their time, and for that you might want to have a parallel job concept there, where this particular VM can take up multiple jobs at a time to run from different build definition. And for that parallel jobs you have to pay in Azure pipelines. So Azure pipelines comes with one parallel job, okay. More than one parallel job, you have to pay for it. So that kind of capacity, that kind of dependency you need to look at if at all you are using your build definition on scale. If you have a large team, if you have a different team who are going to access the same agent, same build agent for running their build, then you have to look at how you can reuse the same build agent using parallel jobs instead of spinning up another VM. So if you do not have the parallel job, then what you will do? You will run another VM. Now in that case, suppose this is something costing you some uh, suppose $8 per hour, just an example. Similarly you will be costing $8 per hour another one. So you might not want to go into the extra thing. You might want to run a parallel job on the same VM because you think it is 8 vCPU and suppose 32 GB RAM, just an example. Then this build is just using some 0.5 CPU and 1 GB RAM. So that way, you know that from the capacity point of view, they all can run. It's just that you need to enable parallel job. For that, you need to look at the configuration of the software that you are using. In case of Azure pipelines, this is a paid option that you have to go through. No, the third thing, which is the fourth thing, which is the last thing, is agent access. So when you are setting up your agent, you might not want access to give access to everyone to run their build against it. So suppose you have your organization, and as we have discussed with Azure pipelines, you get 1800 or 1800 minutes of free build pipeline for your organization, and you might want to run those free minutes for small teams, for development teams, for those teams who are just running some dev test kind of or some POC kind of projects. In those cases, you might not want to give them the paid infrastructure that you have for your private agent. In that case, you need to control that agent access so that you can kind of control no so that when someone is using the paid infrastructure, you know that you are already consuming the free options that you have from the Microsoft. So that aspect you need to make sure, so that you are optimizing the build capacity, the build agent capacity. At the same time, you are making use of all those free features in a very optimized way. Now, having all these maintenance options, aspect of it, then you comes to the point where you want your organizations to look at all the builds in a very standard way. And we have already discussed one of these options using a pipeline as a code option. We are going to revisit the same thing here as well, that is using build agent in cloud. So when you are using the build agent in cloud, the benefit that you have is that the first thing is that cloud gives you on demand infrastructure. So as soon as you are starting your build, you are able to spin up the virtual machine, and you are able to use that virtual machine as a build agent, and then you can destroy that virtual machine. So that kind of automation, you can make use of it. Then also, when you are using cloud for your build agent, it is going to give you various options in terms of customization, or in terms of capacity. And at the same time, it is going to save your infrastructure cost as well, because when you are setting up a build infrastructure on prem, you are going to have a capital investment. You have to buy a server, you have to buy a set up the virtualized platform, and you have to do all those things. But if you are running a server in cloud, and if you are making that particular server as a build agent, then you just need to configure that build agent as soon as you spin up the VM, and you are only paying till the time you are running the VM. The moment you are stopping that VM, you are not paying for it. Uh, you are just getting charged for the time you are using it. That way, your capital investment, which is majorly driving factor for many customer to go to the cloud, will be helpful to implement your build infrastructure in your organization. The next thing is infrastructure as code, or pipeline as a code, is going to help you when you are using infrastructure as code to set up your build environment. Then it is a reusable thing, right? So if you are setting up your build agent using ARM template, using Terraform, then as long as you need that particular build agent, you can spin it up. And then the moment you don't need it, your builds are not running right now, you don't think in this coming month you are going to run a build on this particular server, you destroy that server. Then again, next month you need that particular server, you spin it up using your already developed code, that is infrastructure as code. And then that way your build agent will be reusable. At the same time, cost will be saved a lot. The next thing which is coming into picture these days is containerized environment. So a lot of people are going from VM world to the containerized environment, and which is true for build agent environment, build agent ecosystem as well. So you have a build agent infrastructure, right? You can you can kind of build your application using a container approach, and that way it again reduces your cost and reduces your maintenance aspect, because of course, when you are building a container using some Docker file and all, you can reuse it again and again. You can destroy the container when you don't need it, then reuse the same container. And that way, lightweight infrastructure as well as reusable infrastructure, all those features that are coming as a part of container will be helpful in your build agent infrastructure as well. And that is how you can run your build infrastructure on scale, at the same time saving the cost. You don't really have to pay a lot when you are running, because build is one of the thing to automate. And if you are using automation to automate things, right, so it is like double automation. So you can do that if you are using these aspect of your build agent. If you are running your build agent on a on-premises Hyper-V, or or some um, on-premises system, then you might not be able to automate the deployment part of it. And that way you will always use those build agent always running. There might be scenarios where no builds are scheduled on that build agent for entire day. All right, still they are running, and that way you are actually kind of losing those resources in waste, something like that. As we have said, using any one of the approach where you are using build agent in cloud, infrastructure as code, containerized build agent, then you will be able to generate, kind of spin up your build agent on demand. Whenever your build is running, your build agent will be uh, start, and the moment your builds are completed, your build agent will stop, and you are not paying anything after that. So you are just paying for 10 minutes, 20 minutes, 30 minutes, 50 minutes, 60 minutes, whatever the time your build are running. And then after that your agents are stopped. You don't really have to pay for it, but you have to use these build agent templates using these concepts, where you are using infrastructure as code, we are using containerized build, you are using cloud to deploy your build agent. All these things will help you to kind of maintain an infrastructure of build agent which is highly optimized from the cost point of view as well as maintenance point of view. Now the next thing is reusable component. This is again the same thing that we are discussing here, is pipeline as YAML. So if you are running your pipeline as a YAML, you will be able to share that same pipeline across organization to use it again. Do not really have to go through the go from the scratch. You can develop that, you can build the application. If at all your application does have the same kind of application stack, same kind of dependency and everything, you can standardize that particular YAML into a template, and then you can give it to them, then so that it can be a standard template for an organization, that these are the tasks for ASP.NET application, these are the tasks for .NET Java application, these are the tasks for deploying infrastructure in Azure, these are the tasks for deploying infrastructure in GCP, these are the tasks for deploying infrastructure in AWS. So any kind of standard things you can do using pipeline templates. The next thing is variable groups. You can create variable groups. You can create a global variables. You can tell them that whenever you need this, this value, you can use this variable name, and then automatically you will get that value in your pipeline without exposing that value. They will be able to use that value across organization. That way, globally, everyone is using the same value. Same thing for a certain type of task. There might be scenarios where you want to, whenever you are running a, suppose performance testing, you might want to run a particular server with a security information, and in with a security setting that should be coming from a global variable. So all those things will be possible if you're using variable groups. And then similar to variable groups, we have this task groups. Task groups are similar. We have already discussed that if at all you don't want to standardize the complete template, you can standardize certain tasks, task 1, task 2, and then combine them together into a task group. And then in your organization, people can use those task group uh, uh, you know uh, to kind of implement the collection of that task without having to implement the task 1, task 2 again and again. And that way reusability will be there. The last thing which is there is marketplace extensions. So they are, the beauty of Azure DevOps or Azure pipeline is that it is extendable, and it is extendable up to the mark where you can use lot of marketplace extensions which are developed by various third party people and individual contributors, which can extend your Azure DevOps to the third party ecosystem like Jenkins, Octopus, JFrog, name it, you have it. So majority of DevOps ecosystem toolset, they are, if Microsoft is not giving the inbuilt integration, then marketplace extension is a place where you can search, and 90% of the time you will be able to get something which can help you to integrate Azure DevOps or Azure pipelines with that particular ecosystem, those popular ecosystem. And there are a lot of them, and if you are making use of those marketplace extensions, you don't really have to develop your own custom approach to solve certain things. So suppose Microsoft is not giving you a way to do certain things with SQL Server, do certain things with Azure, or do certain things with GCP, do certain things with AWS, which are outside of Microsoft ecosystem, and the feature is not available. Marketplace, you can search, and then probably you will be able to get something out there which can help you to kind of reuse the things which has been developed by certain other people. And Microsoft Azure DevOps also gives you a way to develop your custom extensions as well. So suppose you have a need where you want to kind of implement a custom logic in your organization, and you don't really want to share with publicly, you don't want to really publish it on a public marketplace extension, because this is very much something which is intellectual property for your organization, or maybe it is very much specific to your organization need, and you might not have that particular. So you can develop your custom extension with that is having the custom logic to do certain things in your organization, and you can privately release it within organization, within company, and you do not really have to publish it to the marketplace. But suppose there is another good feature about this particular custom extension is that just like other people have published it in the marketplace, if at all tomorrow you think that this particular custom extension does not have any intellectual bounding, and your company is ready to share this particular thing with the community, where suppose you have done some custom work where you are doing certain pipeline things or certain automation with one type of cloud platform, or one type of platform like uh, Jenkins, or maybe you are doing something with Azure, or you might be doing something with one service in Azure, Power BI or something, and you think that releasing it with the community will be a great cause, because you have developed something and it is really useful for people, because a lot of people are doing that particular task, but they have to develop their custom way, or they might have to look into workaround. So that way you can publish your custom extension as a marketplace extension publicly as well. So both options are there. You can either use a publicly released extension from someone else, you can develop your own custom extension and privately use it, and you can develop your custom extension and publicly release it and then let people also use it. So these things makes Azure pipelines a really reusable friendly tool, and similar kind of approaches are available in other tool sets. And that particular aspect you should be looking at whenever you are developing your build pipeline, whenever you are maintaining your pipeline. You should always look at all these things, so that you in a longer term you are able to improve the pipeline, and you are able to reuse the components that are being used in pipeline, and you are able to improve the performance of your pipeline, and you are able to reduce the cost that is going into the pipeline infrastructure over period, all using all these best practices, using all these things in picture. Now with this thing, we are going into a 10 minutes break. All right, after 10 minutes break we are coming back, and in that after break Nitanshu will be share, going to have a demo for this particular thing where he will be setting up continuous integration in Azure pipelines. And there he will be creating a basic build pipeline using a template in Azure DevOps. There he will be helping you to go through the interface. How do you track your pipeline? What are the various important interface or various important points that you can look at during reviewing or troubleshooting of your pipeline run. And then he will be setting up a continuous integration build where he will be triggering the build using changes into the code, and then automatically running the build based on that those changes. So we'll be doing this demo after the break. So let's take a 10 minutes break. We'll be coming back with the demo. After demo, we will be having the quiz. We will be also announcing the winner of the last quiz, where we will be, having a lottery system. We'll be sharing random name. We will be looking in the random name, and based on those, the lucky winners, we will be sharing free exam vouchers to them. Okay, so let's come back within 10 minutes and then we will continue the session.
All right. So we are back. Nitanshu, you there?
Yeah,
Yeah, you can go ahead and share your screen and let's start the
yeah,
session.
yeah. So welcome back, guys. This is Nitanshu. I'll walk you through the demonstration today. So in today's demo, we'll be covering how to create a continuous integration pipeline from predefined ASP.NET template. So let's get started. So as you can see on my screen, there is Azure DevOps portal in front of us. So there I have already created a project. So we have some repositories here. So in those repository, I already have one project which is a basically a .NET project with some .NET code and various things. So what we'll do is we'll just go to the pipeline and we will create a new pipeline from here. We'll click on new pipeline. Then you can see uh, uh, there are various options here with in which you can select your source, like where is your code situated. So it can be Azure repository, it can be Bitbucket, GitHub, or some other Git as well. So uh, this is for the YAML code, like if you want to create your pipeline in YAML. But like Ashish told you that you can create a pipeline using the classic editor like you can do in Azure. So for this particular demo, we will be using the classic editor. So I'll just click on the classic editor and there we'll select Azure Repos Git. Yeah, there also we have other options as well like TVFC, GitHub, etc. And I'll just select my project, that which is my project, my repository, it's parts unlimited, and we'll be using the master branch to create the build. So I'll just click on continue. And here you can see that I have several options here. So if I want to use any predefined template, I can select it from here. So that's you can say that that's the beauty of Azure, that that you can have the templates here so that you don't have to work from scratch. So you can just select the template and you can just carry on your work and get going as soon as possible. So I'll just click on apply. And there you can see we have several options, like so this template this template basically works on 6 stages. So the first stage is this is NuGet. So NuGet is basically for some dependency packages that this code might need. So the NuGet store handles that package dependencies, and then the stage comes which is called the build solution. So build solution is basically the main task that builds the solution that and merges the code with the existing code. And then the last one is the test as next one is the test assemblies. So in which we have several tests that got performed on the code. And then the last one is the publish artifact. So as soon as all of these previous stages get successfully completed, so one artifact gets published in the Azure this artifact stage. Then here you can see on the top we have several options here. So the first one is the variables. So variables are basically the general variables, are the common variables that you might need during the deployment of this build. So maybe if you want to change, like Ashish told in his demo, in his when he was talking about these variables, like you can also just in case you want to change your connection string while creating the build, so then you can use these kind of variables to store your connection string and get going, and you don't have to hard code anything in that case. Then the third part is the triggers. So this is the part where you know where the automation comes in place. So these are the triggers that we use when we want to automate our CI pipeline. So we have three options here. You can see one is this here. If you can see this scheduled. Second one is build completion. Third one is enable this one. the option where we are enabling the trigger. So when
Nitanshu,
yeah,
let me pitch in here. So can you
yeah,
just go ahead and enable, click on the enable continuous integration?
yeah, yeah,
So as you can see, as soon as Nitanshu is enabling the continuous integration, it pops up where you can select various filters. One of the filter is branch filter, where it's saying that whenever there will be a change in master branch associated with this build. Okay, so when if you remember, when Nitanshu was starting the creating the definition, he was selecting a repository. So in that repository, you can select a particular branch or you can select multiple branches. So here we are going to select only master branch. So whenever there will be any change in master branch, there will be a build trigger automatically. So you need not to go to the system and start the build. It will automatically start the build as soon as you will change anything in master branch, and we'll be showing it in the later part of the demo where you will be making some changes and it will automatically trigger the build. Similarly, not only branches, you can do the path filters as well. Now when you create a path filter, you create a build for changes in a particular folder. So that is something we are not going to create right now, but that is the one option that you have. And now if you look at the left hand side of the system, on this page, there you have scheduled and build completion. So as we have discussed, scheduled is something you might want to run a nightly build, you might want to run a build at a particular time, or a particular time in the day or in a particular time in the night, when no one is there, systems are idle, things can run without having to impact anything. So that's something you can do. Similarly, you have a build completion thing where you can click on where you can create a kind of connection where anything that happens on the other build system, then only this build will be triggered. So this kind of trigger system is available. You can make use of these complex combination to kind of automate the build trigger in your environment as and when things are changing, based on path, based on schedule, based on branch and all. Yeah, Nitanshu, please carry forward.
yeah. So the next tab that we'll hover over to is the options tab. So here you will see we have various build properties like the naming convention for the build. You can see that build number format. So in this format, the build will be the naming convention of the build. Then you can see there are three options: enabled, paused, and disabled. So as soon as you create a new build, so by default, what you can select what you want to do with that build. Like if you want just want to if you want that as soon as my build is created, it's got in the enable state. So like as soon as the you save the build, it will go into the run mode and create a build as soon as the agent is available. And if you want to do like as soon as you create the build, you don't want to run it, but you want it in a pause state, so you can do that as well. and and here you can see that build in the build job properties, you can select the timings that if a build is creating a too much time, how much time in minutes that you want to give it to, so that it can complete, or if it doesn't get completed, it can cancel the job or timeout occurs. Then on the next option, we have some retention. So what you can do is retention basically is for that how many till how many days you want to, so like you created a build and you run it, and how many days you want to store it, like in the history of the like you can for activity log purposes, like so how many days you want to keep it, like so days to keep artifact symbol and attachment. So here by default value is 30, so it will keep it for 30 days, and after that they got deleted automatically. So in the history right now there is nothing because we are creating it anew, but you can track the changes into the this tab by going to this tab. So we'll just click on save and queue here, and we'll select all the default option. Agent in the agent pool, we'll select Azure pipelines, and on the branch, we'll select the master branch. And we'll just click. And this agent specification is basically the agent version, like Ashish was telling about on the virtual machine that this build will run onto. So this is the specification of that agent. So we'll just click on save and run.
And this is a hosted agent. So Nitanshu has not really created a virtual machine or anything. This particular agent, which is coming to you with the configured, Visual Studio and the proper Windows operating system, is coming from Microsoft. And Microsoft is giving you a certain amount of minutes for your private, project. And for public project, it is like, unlimited. For private project, you have 1800 of minute, entire month you can run it. And for each build it will be 30 minutes. So every build, if it is less than 30 minutes, and you can run it. And as you can see, currently build is running, and on this interface you can see which repository is running, which particular repository is actually connected to this build, which branch has triggered this build. All right, what is the status right now? And if Nitanshu will click on this agent job. Nitanshu, can you click on this agent job
Yeah,
thing? Yeah. So he will be able to see the entire thing, what is happening, which task is running, which task is right now running, which is completed, which is failing, which is passing, if it is failing, due to what error it is failing. So Azure Pipelines gives you a lot of verbose information there, where you can see if at all something is not going correctly, if at all things are going correctly, then what are the things are being run, so that over period you can optimize this particular process. And as you can see, this is showing you how much time it is taking. Right, till now it is 1 minute few seconds, and then total how much time it is taking. And since it is a time that you are getting from Microsoft, and free is limited, also it is on your server as well, on our private on your private build server as well. It is a time that you are consuming, so you might want to optimize this timing. Using this interface you will be able to figure out what are the things are there and how you can optimize this particular thing. Okay, I think it is finished. Now let's go. Yeah, now, yeah, Nitanshu, would you like
yeah.
to talk?
So you see that the agent job got successes. So we got a build created from this, but this is the actually manual process to do this, like creating a new pipeline, and as soon as we created on save and run, it got run. So now we'll see how to
And
automate.
one more thing here,
Yeah,
before going back to the running it automatically, you can see this after finishing the pipeline. You can see this, there is a one published artifact, and if you click on this, Nitanshu, one published artifact, uh, you know, the on the release, yes, this one, yeah, yeah, click on that, release, publish it,
yeah,
published artifact. Back, go back on the main page. Go back on the main page. Yeah. There, if you click on this one published artifact, just adjacent to the timing.
yeah. One previous.
Yeah, so you see this, what is the thing that has been published, and this is the artifact that has been generated after the build, and this is what we call normally artifact. Now this is your artifact after successful build, and what is recommended, you should not make any changes in any of the file over here, XML, .NET, Java, whatever it is. If at all due to any reason you are required to make any changes over here, you are recommended to incorporate that particular process into the build pipeline itself, so that whatever the changes you have to do it after this, you will do this as a part of build itself. So this is the artifact that we are normally calling during, during our DevOps pipeline. We call that, after build pipeline you get artifact, and this is what this artifact is. Now let's, yeah, Nitanshu,
Yeah.
you can.
So now let's automate that the pipeline that we have just created. So as you know, while while we were creating the pipeline, so we saw we selected the branch there. So that branch, and Ashish told us that as soon as we created a checkbox there and selected a master branch. What does that means is, as soon as we make a change in master branch, that the pipeline will get invoked. So we'll just go and just try to make a change in our master branch. So we'll just uh, go into the code, and we'll just select this page, and we will just make a cosmetic change in here. So, and I have made a changes, and as soon as I'll click on commit, and this commit gets completed. So so this commit got completed, and we'll just go back to the pipeline. So there you can see that this build got automatically created, and this pipeline was invoked. And here we can see it is currently in the running mode. So just like we created when we did it manually, and now it is in onto the same stage into the running mode, and we'll just click on agent job. So there we can see a lot of Vouchers information, like on which stage it is currently right now. So eventually this build will also get succeeded. And so Ashish, that's it for I think today's demo.
Yep. So this is how you can see this, how Nitanshu has, created a build pipeline quickly using a template that is there in your Azure DevOps. There are a couple of, template that has already been provided by Microsoft. So you don't really have to think, if at all you are using one of the popular stack like .NET, Java, or Node or Python, then Microsoft has already published those templates in there. You can quickly start using those template to build a general pipeline. You can start configuring it with your custom changes or the custom needs, but you can start it. And then we have shown that it is very much customizable. You can go there and you can look at the interface. You can trigger the build based on schedule. You can trigger the build based on path. You can trigger the build based on uh, you know branches, and as well as you can trigger the build based on another build completion. So these are the things you can configure, and then later on you can configure the retention period. You can look at the history, what are the things there. And then we saw that in the current screen, you can track the whole thing, what exactly happening in each task on the build agent. And in our case, the build agent is a hosted agent by Microsoft. So we don't really have the remote access to the server. We cannot do the RDP or SSH, but at the same time, we can see what is happening over there. And if at all something is failing, it gives you a really nice interface where you can see, okay, these are the commands which are failing. Maybe I need to look at the code. Maybe I may need to look at the packages that I'm using. Maybe I am not using the correct package. Maybe I need a different agent, or maybe I need to install a runtime before I trigger my build, or all those things are possible using that interface. And this is the way you can quickly start. It is free. For first 5 users, it's free. 1800 minutes is free. As you can see, for a standard .NET application, it took less than 2 minutes. I mean, less than 1.5 minutes as well. And so that way, 1800 minutes is a quite reasonable minute that is being provided by Microsoft to you free of cost, and you can use it even for private project. And for public project, suppose you are running a public project, you are running an open source project, it is entirely free. So you don't really have a 1800 minutes limitation over there. So having said that, this is what we had for today. Now let's start the quiz for today. We Let me share my screen. So Nitanshu, I'm going to share my screen.
Yeah, okay.
So let me share my screen again to start the quiz. Okay, just share. All right. So this is the this is the quiz URL that you are supposed to visit: azureeasy.com/az400. This is the URL, or you can scan the QR code. It will also redirect to your browser the to the quiz for today. Make sure you are answering all the questions and putting your email ID and username, I mean your name there. We will be using that information in case you win the voucher. Let me post the same URL in chat as well.
And Ashish, this link will be active for 10 minutes only for all the participants. So they all have to complete this quiz. So within 10 minutes from now.
Yes, thanks, Vipin, for yeah. So we will be tracking within we will be kind of disabling this link after 10 minutes. So make sure you answer the quiz, all the questions within 10 minutes time. So I have posted the URL in the chat as well. If at all you are finding difficult to open the link from the browser by typing or from the scan QR code. Okay, so let me at the same time. So we are having the URL on the screen. If at all you are not able to open, please go ahead and scan the QR code. And at the same time, we are tracking the time. So make sure you are able to finish the quiz within 10 minutes. Okay. So 10 minutes you have. In the meanwhile, I am also opening the quiz Q&A. If at all you have some questions, please post there. We will try to answer all the questions. Just in case we are not able to answer the questions due to time limits, we request you to join our Telegram group and post the questions over there. We definitely answer there after session. We all are part of the Telegram group. We not only you can find the sessions details on the Telegram group. If you are there in the Telegram group, you will also find useful information. You can connect with flow community members. And let me just post the group link over the chat. We also discuss various things about DevOps and Azure in general. So you can discuss issues, your real-time issues, your day-to-day issues that you are facing in the infrastructure, and you can connect with the experts, or you can know the learning path and all those kind of basic as well as expert level information that you may not be able to figure out due to proper networking or community. So we have a very good community of expert people in the group, and we really discuss so many things over there. So I highly recommend everyone to join there. If you are not part of the group yet, we continuously share all the information related to our community over there.
So I can see that many people are responding to quizzes, and this quiz link is about to expire now.
Okay, Vipin, can we extend it for 2 minutes? Actually, in the chat, I have added extra dash in the link. So because of which it has created confusion for few. So let me correct that
Okay,
one.
we'll be waiting for 2 more
Yeah, we'll
minutes.
be extending it for next 2 minutes.
Okay.
Just by mistake added that extra. Okay, just let me correct that one. Okay, so I have corrected the URL, guys, and I have also posted the correct link in the chat as well. Due to one dash, additional dash, it was, but we are going to extend it. Sorry for those who are not able to access it, but the QR code should be working fine. There was one, link that we have mentioned in the chat, which was incorrect.
Many participants use this QR code. I can see that
Yes,
lot of
it
people
was just
have
one instance
attempted
where
for this particular quiz.
yeah.
And I can see that almost all the participant is trying for this particular quiz.
Yes.
So 1 more minute to go. So this quiz link is disabled right now, and I appreciate all the participants who attempted for this quiz. Ashish, now it's over to you. You can announce the winner for the last quiz and carry on.
Okay, so let me share my screen. Just give me a moment. Okay. We are going to open the link and we are going to open a lottery system where we'll be giving the free vouchers to those people who have kind of attended the previous session and did the training, did the you know the quiz like today's. Just give me a moment. I'm sharing my screen in a bit with the participant information. So, okay. Okay, so as you can see, we are going to have a shuffle from a list of names that we had in previous session.
So as you can see, we have 35 entries based on the people who were part of our previous session, and they also registered on Eventbrite page. So when you are taking the session and when you are participating in the quiz, just make sure that you are also registered on our Eventbrite page that we have for, so that you can also get the free the future session updates. We are planning new training tracks as well. You'll be getting all those updates as well if you are registered there. So let me go ahead and run the first winner uh, wheel, and let's see who is the lucky winner. So from the lucky winner, we have this Pradeep, and I'm going to save this information in our database. We'll be connecting with Pradeep after the session, and we'll be sharing the Azure voucher with him. Now let's run this wheel again, and let's see who is the next winner. So this is this email ID. Let me just check the name. Okay, as per our database, Control C. So the name of the person is Devraj. We'll be connecting with Devraj after session for giving him the voucher. So let me remove him from the list. And then we are again running the wheel. The third winner is email ID with Deepak. Let me save it. And fourth winner is Lohit. Congratulations. So we are going to save his name. Now run it again. Oops. What happened? Okay, so now Rao. So Narsimha, you are again winner of this quiz. So this is total 5. The last winner will be, let's see. And we have this last winner. Good. So this is it for the winner. Congratulations. And those who have participated in today's session, they will be they will be selected in the next session. In the next session, we will be having a similar uh, lottery system where we will be selecting those people who have participated in today's session, and then we will be selecting a few to give the vouchers based on the availability of vouchers. And thank you so much for joining the today's session. And just as a final, let me share my screen. So this is our group information, and this is our speaker information. Nitanshu, you can reach out to Nitanshu on this LinkedIn URL. And if at all you want to connect with me, you can reach out to me on my LinkedIn URL. You can also visit my blog
AzureDevOpsPro.com to see all the sessions as well as all the information about our group. You can register for the future sessions on this URL azureeasy.com/az400 az-400. There you will be getting Eventbrite page. If you are registered for sessions there, you will be getting all the updates about the session as well as the recording session details, and you will be eligible for the vouchers if you will participate in the quiz in respective session. Uh, you can also join our Azure Talk group, which is a Telegram based largest Azure community. We have more than 8,000 people over there. Lot of expert, lot of beginners. So whatever query you may have related to Azure, in terms of learning, in terms of your career path, in terms of your real-time issues that you're facing when you're implementing certain services in Azure, you can, ask those questions over there. Uh, Community members, including the core team members, uh, behind the scene who are working behind the scene for this session are available there to help you to answer those questions. We try to help each other to grow their learning in Azure. You will be getting updates regarding sessions. You will be getting updates regarding the recording, locations, slide deck and all. In addition to that, you can connect with us there in real time. You can message to all the community member. More than 8,000 people are there to help you. Similarly, we have Azure DevOps Pro group on the Telegram application itself. It is again a group where you can talk anything and everything about DevOps and Azure. So it is a group where you can discuss anything that you may have issues or you may want to discuss about DevOps, or you may want to discuss about Azure implementation of DevOps. So we have like more than approximately 2,500 people, and we are growing very fast. And there you can there are experts, there are beginners, so all types of questions are welcomed. Everyone can help you there, and we all help each other to learn more and grow together in this particular technology. We have our YouTube channel. There you can search Azure Talk. There you can find all our previous session recordings as well as all the recordings that we are going to, all the sessions recording that we are going to have, including the current session, will be hosted on this channel. So you can go there and subscribe to the channel to get all the latest update from our channel as well. So this is a quick information or quick detail about us. Uh, Thank you so much for joining our session today. Uh, do join us in future session where we will be discussing about other modules, other topics that are part of AZ-400 exam. After completing the entire session with every module, you can go ahead and do self-learning based on the materials that we'll be providing as part of this recording session, as well as some learning material from freely available learning material. And then you can plan your exam. And of course, in each session, we are giving away certain vouchers. So if you are the lucky winner, then you can actually appear for the exam entirely free of cost. So with that, thank you so much, everyone. I really would like to thank everyone behind the scene, core team, Azure Talk community, and you, everyone who are making us, to enabling us to share all the knowledge or to help us to grow together in this particular ecosystem. Thank you so much. Have a great day. So.